Today's lesson is about the real number system. We're going to talk about what numbers fall into the real number system, the different categories of the real number system, and how those categories compare and contrast with each other. Let's get started. Okay, so what are number systems? I just kind of explained. They're categories of numbers. So just like you can categorize pretty much anything, we can categorize numbers and get, based on their characteristics. So each category of numbers is going to have specific things in common. And again, some categories are going to kind of overlap. So when we start putting numbers into different subsets or subcategories of the real number system, they may fit into more than one category. You have to pick the best category that they would fit in based on the most specific, explanation or description of the number. You'll see more about what I'm talking about when we get into categorizing the number. Okay, so let's talk about the real number system. The real number system is composed of two types of numbers. We have rational numbers, and rational numbers are all numbers that can be written as a ratio or a fraction of two integers. So the numerator and denominator both have to be integers. The irrational numbers category are non-repeating, non-terminating decimals. So you can see there's examples of both below. Some examples of rational numbers, you see fractions there, integers there, decimals there, a repeating decimal, because repeating decimals can be written as fractions. That 0.6 repeating would be 2/3. You wrote that in fraction form. Improper fractions, whole numbers. On the irrational side, you see numbers that are non-repeating and non-terminating. So most of you are familiar with pi. Pi is 3.1415, blah, 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 blah. It keeps going. It doesn't have a pattern. Some people have memorized a bunch of numbers of pi, but that's because they have good memories, not because they can figure out patterns. A lot of square roots that are found that are not perfect squares when you begin also are non-terminating, non-repeating decimals. So like the square root of 49 is 7. So the square root of 49 would fall into the rational numbers category. The square root of 2, however, is a non-repeating, non-terminating decimal. It doesn't end, it doesn't repeat. If you type that into a calculator, you would see that. So that's why it falls into the irrational number category. Okay? So what you need to remember about irrational numbers is it's numbers that, kind of like the ones you see there, it's square roots that you can't solve by having a perfect square, or it's numbers like pi that don't repeat and don't end. So we're going to focus mostly on the rational number system, or subcategories of the real number system today. Irrational numbers kind of end there. That is a category. Okay, there are no subsets right now that we're going to talk about of irrational numbers. But rational numbers have some more subsets we're going to talk about. So let's take a look at those. Okay, so the first one we're going to talk about is integers. So integers fall into the rational number category because they can all be written as a ratio. And if you remember, integers are just the numbers that are whole numbers and their opposites. So you can see here, I started a list, I put 0 in the middle, and I can start counting up from 0, 1, 2, dot, dot, dot. And then in the negative direction, -1, -2, dot, dot, dot. If you continue those patterns, that would eventually show you, as long as you feel like you want to keep writing, a set of integers. Okay, so integers are technically rational numbers and integers. They fall into both categories. So if I asked you which category of numbers would -4 go into, you could say that -4 is a rational number, and it's also an integer. So integers are the more specific category, though, because rational numbers can also include fractions and decimals. The integer category does not include fractions and decimals. So the best way to describe the integer category is it's all rational numbers that can be written as a non-decimal or non-fraction. So you can see in my example list, those are all non-decimals and non-fractions. So those are integers. Okay, but again, if I ask you which category -1 falls into, -1 is a rational number and an integer, but the best answer you want to say is integer because that's more specific. Okay, so that's one subset of the the rational numbers category in the real number system. So there's a subset that goes on from there too. And the next subset is whole numbers. Whole numbers are the non-negative numbers without decimals or fractions. So if we take a look at the list of numbers I'm talking about there, we're starting at 0 and just counting in the positive direction from 0. So non-negative numbers without decimals or fractions. So what you can hopefully notice is that whole numbers are just the integer category without the negatives. So if I gave you a number, these are all integers that are not negative. That's the best way to describe it. So if I gave you the number 4 and I said, tell me out of the categories you see right now, tell me the best category for the number 4, you would tell me the best category is whole numbers. Okay, 4 also fits into the integer category. It also fits into the rational number category, but the most specific category it fits into so far that we've seen is whole numbers. Okay, so you can see like that certain numbers fall into multiple categories, but you want to pick the best one. Right? The next category are natural numbers. Okay, so natural numbers are the positive numbers without decimals or fractions. So think about this for a second. Look at the definition of whole numbers, non-negative numbers without decimals or fractions, and then look at the definition of natural numbers, positive numbers without decimals or fractions. What's the difference? I'll give you a hint. There's only one number that gets left out from the whole number category to the natural number category. And that number, if you look at the list, is just 0. So natural numbers have to be positive. So the quick way to think about this, all of the whole numbers except for 0. Okay? So if I gave you an example and I said, tell me which category the number 1 falls into. What's the most specific category the number 1 falls into? Well, you know that 1 falls into real number, rational number, integers, whole numbers, and natural numbers. But the most specific category it falls into is natural numbers, because that's all of the whole numbers except for 0. It's all the positive numbers without decimals or fractions. Okay? If I asked you about the number 1/2, for example, if I said, tell me what category the number 1/2 falls into, start with natural numbers. 1/2 does not fall into natural. It does not fall into whole. It does not fall into integers. So the best category that you can say for the number 1/2 is it's just a rational number. It doesn't fall into any of the more specific categories after that. Okay? The number 0 falls into the whole number category. Okay? The number -2.5, if you look at the categories again, -2.5, it doesn't fall in the natural, not in whole, not in integers. So -2.5, it is a terminating decimal, and it's negative. That doesn't really make a difference with the categories here so far. But -2.5 would just be a rational number. Okay? If I said the square root of 51, the square root of 51 can't be simplified as a whole number because it's not a perfect square. 51 is not a perfect square. So that would be an irrational number. Okay? So that's what we're going to practice right now. Okay? I want you to take a minute and hit pause and write down these numbers, or on your notes, if you have your notes, you can write next to the number the letter that goes with the number that you see, and be as specific as you can. Okay, you want to be the most put down the most specific numbers that are specific letter that goes with the number as you can. Okay, so take a minute and pause. When you're done, I'll show you the answers. Okay, there you go. So here are the answers. 21 falls into the natural number category. Okay, it's a positive, non-decimal, non-fraction. -5 is an integer. It doesn't fall into the whole number or natural number category because those are only include numbers from 0 up in the positive direction. Some things to look at. Pi, again, pi right here is an irrational number. The -0.3145 ... There's no pattern with those decimal digits. So that's an irrational number. And the square root of 3, 3 is not a perfect square, so you can't solve that kind of using times tables. So that would be an irrational number. Okay. Everything else is either rational. If there's a fraction or decimal with it, and it's written like the 5 3/5 or the 2/3, those are rational numbers because they're written in fraction form. However, they don't fall into any of the more specific categories. Okay. Take a look at 25 and the square root of 25 and the opposite of the square root of 25, or negative square root of 25. The answer to the left one here, that would just be 5. That makes that a natural number. The other one would end up being the square root of 25 is 5, but that negative sign's hanging out in front. So that answer would be -5 when you solve that. That makes that an integer. Okay? 0.257, that's a terminating decimal, so that makes it rational. Okay? And you can go through and look at the rest of them. So we're going to categorize the numbers based on the subset they fall into. So we'll get a lot of practice with that. We're not going to be solving really anything in this unit. It's just categorizing the numbers. So if you need to rewind, rewatch, go ahead and do that. If you need to come back later on while you're working on something to take a look at it again, go ahead and do that. And I will talk to you next time.